Okay, Assalamu alaikum. Welcome to lecture 4 of data mining. Uh, so we had our last lecture last Tuesday. We did not have a lecture last Thursday. So this is lecture 4 in this course. So we'll make up that missed lecture later on. I'll let you know. So I hope all of you are doing well. COVID is spreading quite widely these days. I think I was also infected by COVID last week. So, but I'm better now, Alhamdulillah. So today we will start data pre-processing. But before that, I will mention a few things. Things that as a data scientist, as a machine learning engineer, which most people who take these courses can have a role or title, need to think about before processing or analyzing the data. So I will start with that, and then we will move on to data preprocessing, which is chapter 3 of your textbook by Han and Camber. And then, of course, also later today, we have a quiz starting at 1:35. The quiz is 10 minutes long. It is linear in the sense that once you are done with the question, you cannot come back to that question. So most of the questions are short. I think all the questions are short. Some of them are MCQ, some of them are small answers. And so please have your camera on during the quiz, and please follow all ethical rules during the quiz. So the whole idea of taking this quiz is to test you regarding your understanding, and it's for your own benefit so that you can learn. And I mean, obviously, if you anyway, so you understand. So no cheating, and of course you can have. So ideally, you cannot have anything open besides the quiz. So during the quiz, and that's why we want you to have the camera on, and you cannot communicate with others during the quiz. So, and you also have your first assignment uploaded. So please start working on the assignment as soon as possible, because as we move through the semester, your workload will increase and time management will become a problem. So try to wrap up things as soon as you get them. I did not get your question. What did you ask about? No notes? Yeah. Yeah, I mean, you can use the notes, not a major issue, actually, just 10 minutes long. Uh, Ideally, you should not look at other notes, other stuff. And in general, looking at notes and stuff would benefit you much in most of my quizzes. So, and but of course, you cannot for sure communicate with others.
Excuse me.
Okay.
Sir, as long as we are not communicating to others, it's okay to refer to our notes.
कर सकते हैं क्विज में इसकी स्ट्रिक्ट पॉलिसी मैं नहीं अपनाता एग्जाम्स में जो पार्ट होता है उसमें मैं करता हूँ बट द पॉइंट इज यू हैव ए लिमिटेड टाइम इफ यू जस्ट फोकस ऑन द थिंग यू शुड बी एबल टू सॉल्व इट प्रॉपर्ली तो आप नोट्स को देख सकते हैं बट my experience is that you wouldn't benefit much from looking at notes at that point in time.
Okay, sir. Thank you, sir.
But it has to be on the computer or maybe just besides the quiz because we will be monitoring you on the camera. All right. So let's get started then. Any other question? Okay. Okay. All right. So last time we were talking about data understanding, and along with data understanding, the idea was that we wanted to get an understanding of the process or domain from which that data is generated. So that's a key goal of uh, data understanding as well as data preprocessing later on is to get a hold on how the data is being generated and to understand the processes that lead to that data. So basically that is called business understanding or domain understanding. So uh, from a machine learning or statistical perspective, what you actually have is a sample from a population. So meaning that you have uh, so so that's the statistical viewpoint of it. You have a population which is the entire set of possible observations. From that possible set of observations, you only have some part of it. You don't have the entire set of. You don't know everything in the world. You have part of it. So that's a sample. So you need to understand this concept because what we do at the end of the day, we analyze the sample. In other words, we apply data mining on the sample, but our goal is to generalize to the population, meaning that whatever you have discovered from the sample, you ascribe it to the population. So just to give you a simple example, let's say we talk about students at LUMS. Let's say you analyze uh, the behavior of students from, let's say, those who graduated 2021 or those who will graduate 2022, undergrad students who will be graduating in 2022. Let's say you discover some interesting patterns regarding those students. So that in a way is a sample. And if you ascribe that discovery to the entire LUMS population since it was started, so that, I mean, if you consider that to be the population, then you are kind of generalizing that information to the entire population, even though you have applied or you have done the analysis only on the 2022 batch. So this is the distinction that you need to understand while doing the analysis and after you have done the analysis and you are interpreting the results. So sample and population. The other thing is you need to know about is that whenever you have data, you need to think about the data generating process. So how is that data generated? Because as a data scientist, maybe you just have a database available with you and you don't really understand how that database is populated. So you need to have a deeper understanding of the actual processes involved behind the population of the data. So, and it might happen that there might be multiple processes that are involved in building one relational table, for example, a database table. So you need to be able to understand all those processes. So again, to give you a simple example, let's say if we think about students at LAMS, so one process is taking courses. So once students take courses at LAMS, as they take courses, they enroll in courses, they take the various uh, grading instruments within those courses and eventually get a grade for that course. So that's one process. So another process might be for the same student, might be, let's say, admission into LUMS. So another process might be, for example, so you are talking about the same entity, but there might be different processes that are generating those data. Maybe that student participates in sports, for example. So information for sports uh, would be a separate process. So you need to be able to understand and relate your data to different processes of that organization or business from which that data is collected. And again, the idea is that we would like to analyze the data, meaning that you are discovering things from the data, but at the end of the day, you are generalizing to the process, meaning that uh, you have taken, let's say, the same example, let's say 2022 batch students' performance at LUMS. Uh, you analyze that data, maybe find some interesting patterns, and then you say that this pattern is representative of all batches at LUMS. So that is the process that you are studying. So this is something that you need to keep in mind, and you need to make sure whether this representation is really important, correct or not. And we will discuss some issues shortly. Okay, so some overview of typical analysis categories. So you need to know about the difference between observational studies or analysis versus experiment or experimental trials. Uh, so observational analysis is basically analysis or studies done on data for which you do not control the variables of that data. You don't have control over the variables. So for example, again, taking the example of students take courses at LUMS, they perform at various courses, they get various different grades. So as a data scientist, as a machine learning engineer, you do not have control over those students and their grades. So this is called observational study, and the vast majority of data mining is observational study. So you have data that has already been collected. You do not have control over what those values are or how those values should be. You just have the data, dump of the data, and you are doing analysis on it. On the other hand, experiment by its very nature is something that you design and you control. So maybe, for example, again, taking the example of students, maybe you have some specific goals and you conduct an experiment, maybe saying that, let's say there are two courses, CS, let's say 432 and CS 536. And you control who enrolls in CS 432 and who enrolls in CS 536. And then maybe during the course as well, you control other aspects as well. Maybe uh, the difficulty of a particular assignment in 432, the difficulty of a particular assignment in 536, and then at the end of the day, you do the analysis. So this is like an experiment. You are controlling the entire data collection process. So usually, most data mining is not on experiments. Of course, you can do that as well. Most of the data mining is on observed data, observational studies. So experiment types of the experiments and the data that comes from it usually are related to subjects like the uh, the medicine or epidemiology and other areas where you are trying to study the impact of various factors over time. So this is one distinction that you need to be aware of. So most of data mining is observational study. In observational study, you do not have control over the variables, over the values, while in experiment, you control the data and how you want to get the data. All right. There are also various subcategories of observational studies. And I'm not going to go into very detail in statistics or maybe in some social sciences courses or maybe even in SSE. I don't know. You might study these things. Uh, so observational studies can be, for example, case studies, case control studies. So here in case control studies, uh, essentially you are taking two well-defined cases, maybe you're trying to study, uh, let's say, males and female students, and then trying to analyze their outcomes. So separately over time as well as space or whatever dimensions and variables that you're interested in, but two well-defined cases. Usually case studies also often comes from the business domain. You have two different companies, company X and company Y. Company X was successful, company Y was a failure. Then you study both and try to find interesting patterns across these two cases. So that's typically called case studies or case control studies, because you have control to some extent, because you're selecting one case with a particular outcome, company failed, another outcome is company passed, was successful. Then we have what is called as cross-sectional studies. So cross-sectional studies basically are studies of subjects, of different subjects at a particular point in time. So for example, you can take a snapshot of all students at LUMS at a particular point in time, their GPAs, for example, at particular point in time, and do an analysis on that. So across your subjects. By the way, all of this is like observational studies. It falls under observational studies. You have data of this particular categories, case control studies, cross-sectional studies. And the third one is longitudinal studies. Longitudinal analysis or studies. So in this case, you are tracking subjects across time as well. So maybe also you're tracking multiple subjects, for example, multiple students, but those students now you're tracking from their first day at LUMS till the last day at LUMS. So you have an element of time in it as well. Longitudinal study. And within longitudinal studies, you have other variants, for example, cohort studies. Cohort study is basically a specific characteristic or group that you're studying. So that's cohort study, and so on. There are others as well, for example, panel studies and so on. By the way, to get a quick overview of these things, you can look at this Wikipedia page. So observational studies on Wikipedia. You will have a quick overview of these categories. And of course, you have links to details for each of those categories as well. So you can use this as a quick reference. I'm not saying that you should be an expert in these things, but you should be aware of these things as a data scientist, as a data miner. And you should know what are their specific applications and usages and how your analysis compared to these categorizations. Okay. Mhm. So, so I have the distinction between observational analysis and experiments is clear. So experiment means that you have control over the data and their values, while in observational study, typically data and the values are already recorded and they are made available to you. And most of data mining is, you can say, observational study. Now, finally, briefly, last time we also talked about the notion of bias. And there actually we said that bias is if a value deviates from its true value. So, so bias is measured value uh, minus actual or true value. And of course, measured value, meaning that if you're measuring that multiple times, you get a mean value, meaning talking about precision. Remember, I made the distinction between precision and accuracy last time. Precision is about repeatability of measurements. Accuracy is about how a particular value deviates from its true value. So if the measured value deviates systematically from the true value, and that difference is thus called the bias. And of course, bias, this is a specific meaning of bias. Bias has a more general meaning, and we need to be aware of that notion as well. So actually, if you study bias in detail, there are various categorizations of bias. I'll just mention a few. So for example, selection bias. So what does this mean? So you are a data miner, you are a data scientist, you had, or I would say you, so for example, again, taking the example of students at LUMS. So you wanted to analyze, for example, uh, performance of various batches, but it was your bias that you chose batch, for example, 2022, and did the analysis on this and then generalize this to all batches. Maybe another data miner would come in and say, oh, no, I would select 2021 batch. Or maybe someone would say, no, I'll analyze multiple batches. So all of these, in a way, are biases that you're introducing into your analysis. So in this particular case, it's selection bias, data selection bias. Which data you chose to achieve your ultimate goal, which was to understand the behavior of undergrad students at LUMS. Okay, so you need to be aware of such biases. Maybe it might happen like the batch of 2022 through COVID was an exceptional bias. It was an anomalous batch. So this might not generalize to others. So things like this should be considered, or you need to think through these things while you are selecting your data. Why, by the way, 2022, why I'm saying this, maybe because of the COVID pandemic for the past 2 years. And then, of course, there are many other biases as well. So, for example, one is called the omitted uh, variable bias. So, selection bias, omitted variable bias, both of them can be related at some level. Omitted variable bias is meaning that you want to do some analysis, but you did not or could not select a particular variable. Maybe that variable was important for your analysis, but you are not given that available variable, or you did not select that variable. So of course, your analysis would be impacted by uh, that decision, and such biases are called omitted variable biases. Mhm. Uh, And then, of course, biases could be in other ways as well. Sometimes biases would be of interest as a data miner or as a data scientist. Maybe you like to find out within your data whether there's a specific type of bias, for example, gender bias. So you might want to find out, for example, again, students and alums, whether there's a bias in the grading of males and female, for example. Maybe this is the hypothesis that you want to analyze. So in this case, bias now becomes a goal of your analysis. So I think this actually this field is quite deep. I just wanted to give you a quick overview. This all boils down to, for example, causal analysis, which we'll touch about later again in this course. But I think for now, I think this is a quick introduction, and I've given you some references on Wikipedia. You can look those up and find more information if you want to. So any questions on this? Okay, so let's move on to data preprocessing. And let me just start with the slides maybe. Okay, so data preprocessing is basically any operation that you perform on the data before the actual, you can say, data mining task. So any and all steps that you do before that would fall under data preprocessing. And as the name suggests, it might involve a lot of steps. But the point to understand is that in every project, in every task, you do not need to do all those steps. Some of those steps might be required, others may not be required, and so on. However, in this course, we will be discussing many of these steps just to give you a flavor of what is involved in those steps and maybe an idea of when to apply and when not to apply. So that is the main idea of going through this uh, chapter. The techniques in this chapter are usually simple. The whole idea again is that we don't want to spend too much time on these steps. These steps should be simple to shape our data, to formulate our data in a way that would help our final data mining task. And one core aspect of or goal of data preprocessing is to improve the quality of the data. So subjectively, you can think of data quality along these dimensions that are given on this slide. So one is accuracy. So how accurate is the data? Again, go back to the definition of accuracy. How the value relates to its true value. So we need to know the accuracy. And again, these are subjective or qualitative ways of assessing the quality of the data. So other dimension is completeness. Is your data complete or not? Is there things missing, important things missing, and important subjects missing or objects missing, important variables or feature missing or not? So this is completeness. Or are there Yeah, I mean, that's completeness. So consistency is essentially meaning that your data uh, should have internal consistency. So within the data, there should not be conflicts. So for example, in one data set, at one place, you have the age of a person as 25, at another place, it has the age 28. So that is inconsistency. So consistency essentially means that within the data, you should have a holistic, consistent view of the process that is generating the data. So timeliness is another dimension. So of course, if you're analyzing, uh, so let's say if you want to study the behaviors of students when LUM started way back in 1985, but then you're using the data for the batch of 2022, so that doesn't make much sense. So, and the flip might also be true. So maybe you have the data for 1985 and you say maybe you can extrapolate it to 2022. So that might not be uh, correct. So again, your data has to be timely, uh, and that timeliness should relate to your ultimate goal of the analysis. So believability is meaning that as a human being, you should find the values reasonable. So maybe, for example, let's say uh, you have recorded the weight of students, and within a column you find a weight of 250 kg. So that is very hard to believe. Maybe that's an error. So in general, while eyeballing your data or maybe doing simple visualizations of your data should make sense to the common human being. And then, of course, interpretability. Your data should be in a format that you should be able to understand easily. For example, if your data is encrypted, for example, or if your data is in some weird, let's say, data structure that you cannot understand, so that also is useless to you. So these are some qualitative, you can say, dimensions along which you should assess your data quality. But in addition to this qualitative, you can also have some quantitative measures, quick quantitative measures to assess your uh, data quality. And those would depend on what is important to you. For example, you can have simple measures like fraction, or sorry, not fraction, percentage of values, for example, missing. So that could be a quantitative way of uh, assessing the quality of your data. So if the percentage of missing values is high, you can say that the data quality is low. So number of inconsistencies, so you can have a measure like that as well. Uh, for example, you can also compute uh, duplicate entries, and so on. So you can define measures like these, which would then be quantitative measures of quality of the data. Okay, so what are the major tasks in data preprocessing? As I said, there can be a lot of tasks in this, but for any particular project, you would not be you will not be doing all of them. So we have categorized these tasks in some. We have grouped these tasks into some categories. So one is basically data cleaning. So the other is data integration. So data cleaning, of course, is primarily or directly related to quality. Uh, Again, cleaning and quality. Uh, the whole idea of cleaning is to improve the quality. But other factors also improve quality as well. So data integration is, of course, related to combining multiple data sources. So data reduction is trying to reduce the size of the data. And that size could be in the number of objects or in the number of features or both, as we will see. And of course, within each of these categories, there are tons of techniques, and we'll be discussing just some of them briefly. So normalization, you can also, so data transformation. So this is another category, and anything that you do on the data that leads to a change in the data can be considered transformation. But of course, this is a separate category here because there are some unique steps that can be done in this. So normalization, discretization, and so on. So we will be studying these as we move along in this chapter. So let's start with data cleaning. So data cleaning basically tackles three issues. One is, of course, the issue of incompleteness or missing values. The other issue is the issue of noise, or you can say erroneous values. So incomplete, noisy, and inconsistent. So these are the three main issues that we typically handle in data cleaning, and there are various steps in each of these. So there are some examples given on this slide. So inconsistency, of course, as I gave an example before, maybe you have the same entity but with different values. So that's an inconsistency. So let's start with data cleaning and the issue of missing values. So why do we have missing values? There could be several reasons. Either the data is not available, or there is some error in the data collection process, or maybe the human that wanted to enter the value did not enter it. And and maybe because of some automatic process, the data was deleted and so on. So there could be several reasons. So if you have missing data, missing values in your database, so what can you do? So, so let me go back. Just wanted to highlight one thing. So whenever you have data available with you, so missing So missing values can be captured in different ways, and each of those may have different meanings. So as a data scientist, you need to understand that. Sometimes it will be just a blank entry, meaning that let's say if you have comma separated database, let's say 3, 5, let's say Asim, and then you have two commas without any values within it. 25, 3, and again two commas. So this basically means that there's a blank, there is no value recorded there. There's a missing value. So that's, of course, when it's blank, of course, you don't have any way of interpreting it other than assuming that it's a missing value. Other times people might add uh, some other value there. For example, -1, like an error code. So you need to understand what that -1 means. Maybe you have to look at the data dictionary or the metadata and find out what that value -1 means. If you do not uh, consider this, then you might be using -1 as a value, a real value in your analysis. But when you look at the data dictionary, -1 simply means that this value is missing, or it may have some other meaning. This value was not applicable, or some other meaning for it. So this is something that you need to be aware of. Sometimes you also have NA written in some uh, value. Again, you need to know what that means. Not applicable or not available. What does it mean? So exactly, you need to know the meaning of that. Sometimes you will have null written there. So null might be a legitimate value in some attribute, but in other cases, it might simply mean that this value is missing. So again, you need to understand what is the true meaning of that value null there. Sometimes you have n written. This is usually an output of some uh, program, which basically means not a number. So there's an error in generating this value. So this error might be due to data transmission. It may be due to data computational error and so on. But NaN might be written there. So as a data scientist, you need to look at the values and be able to assess the true meaning of each value in the data. Don't just blindly assume that you see a value there that it's a true value. So someone has written -1 there, just use that and do your analysis on it. So you need to be careful about that. Okay, so let's say now you have found out the missing values in your data set. So what can you do now? Of course, yeah. So what can you do now? The first thing is you need to decide whether you want to use an attribute or a object for which there are many missing values. So for that, usually you'll have to make a judgment call. So let's say if 5% of an attribute's value are missing, 5 is actually quite low, by the way. Let me say, let's say 25%. So if 25% attribute values are missing, maybe then you say drop this attribute. Because of course, so much information is missing and you can't really do anything about it unless you can go back to the data generating process and extract those values again. If that is not a possibility, then really you can't do anything. Similarly, if, for example, a large fraction of values of an object are missing, again, drop the object. So for example, you have a data of a particular student, but very little information is available for that student. Maybe that is student did get admitted into LUMS, but uh, for some reason or one reason or other did not take many courses. And so even after 4 or 5 years, you have like 4, 5, 6, 10 courses registered under that student's name. So that you have a lot of stuff missing. So each semester there is a semester off stuff. There's no courses being taken and so on. So such cases, you probably delete that record or delete that student's information from your data. All right. Uh, so, okay, if there are not too many missing values and you assume that you can use the data, also there's one other category So usually if a class label value is missing, here also you drop it. So let's say your main task is to do prediction uh, uh, whether a particular, let's say, uh, which example should I take? Uh, mm, so let's say if you want to predict predict anyway. So I can think of the example, a typical machine learning example. I wanted to avoid that, but anyway. So let's say you have a data where you want to detect whether a particular textual content is positive or negative. Uh, for example, you have a tweet and whether it's a positive sentiment or negative sentiment. And so that's the main aspect of that tweet. So polarity, and so that's like the class label. So if a particular tweet does not have a class label and your analysis is based on a class label, then you should drop that whole tweet, unless you can get that tweet labeled by someone with the appropriate label. So that's the idea there. If the important, a key attribute of your data is missing, like the class label, then you should also drop that object. Okay, so that's about dropping. Now, if you don't want to drop and still want to do the analysis, some algorithms will work with missing values. So this is algorithm dependent. So you need to be aware of that. So there are like some decision tree algorithms that would even work if there are some missing values in your data set. But there are other algorithms that would, let's say, crash if they find a missing value in your data set. So this is something that you need to consider next. And finally, fill in the missing values. So if there are few missing values, then you might want to consider filling in the missing values using some simple technique. So all right. So there are some simple ways to consider, simple ways to use for filling in missing values. So if you talk about numeric attributes, maybe you can fill in the missing value by taking the mean of the values. So you can fill in all missing values by the mean of other values. So for example, again, let's say talking about students at LUMS. So let's say some students' ages are not entered in a particular database, but other students' ages are available. So you simply fill in the missing ages with the mean age. So in other words, if there is some person, let's say Asif, with the age that is missing, but all the other students, their mean is, let's say 23, 23.5, you basically fill Asif with 23.5. And all other values, all other students who have missing values will also get the same value, 23.5. So of course, this is also introducing bias in your data. You don't know the true value. You're filling it with some technique, which may not be correct, of course, but you're estimating it using the mean. And that estimate, of course, might be different from the true value. So it's a bias. But it's a judgment call that you need to make, because maybe your algorithm would not work because of these missing values. You need to fill in these values in an appropriate way. And one way is to take the mean of all the other values and fill it with that. So if the attribute is, let's say, for example, ordinal, for ordinal also you can take the mean and replace it with the closest integer to that mean. If it is nominal, you can replace it with the mode. So let's say, uh, mm, so let's say you have a database of colors and there are some colors are missing, then you replace the colors with the most frequently occurring color, or some other examples in which you have nominal values. Uh, so that is one way of doing it, but a slightly better way, and especially if you are able to categorize your data, is to use mean of appropriate categories. I am writing mean here, but depending on your attribute, you will be replacing this with the median, for example, or with the mode. All right. So mean is only computable for uh, ratio scaled or interval scaled attributes. So what does this mean? Again, taking the example of students and their ages. So let's say Asif age was missing, but you also know that Asif is a sophomore or let's say freshman. So this is a category, and this category is giving you some indication about the age of this person. So now instead of filling the age for Asif as the average of all students at LUMS, you fill in with average or mean for freshmen's. So maybe if you do that, you might get a different age here, let's say 18.5. So now you're computing mean based on some grouping of the data, which you feel is more appropriate and closer to the true value. All right. And then these are primarily the two most common simple techniques. You might have more sophisticated techniques as well, but those are usually avoided during the pre-processing step. You can maybe build a sophisticated uh, predictor for the missing value. So that is possible. Maybe learn a machine learning algorithm, maybe a logistic regression model to fill in the missing value. So you can do that. So if that is really beneficial, then you should use it during the pre-processing step. Otherwise, you should not use it and use some of these simpler approaches. So this is about filling in missing values and dealing with incomplete data. So incomplete data is essentially missing values. And so any questions? Okay. So the next thing under cleaning is handling or dealing with noisy data. And noise is essentially So technically, noise is any random error in your observed or recorded data. And and so that's the technical definition. But usually you will be able to figure out whether there is uh, an issue in the recorded value if there is variation with as compared to other values close to it. Otherwise, you won't be able to find out whether the value is correct or incorrect, noisy or not noisy. So that's uh, one way of assessing whether there is noise in the data or not. So there might be various reasons for noise. It might be automated because of data transmission, sensor error, sensor failure. There could be also human errors and so on. So the value that is entered is not the correct value. So how do you handle noisy data? Obviously, the first thing is to assess how much noise there is in the data, and that usually is a very difficult task. You won't be able to figure out the amount of noise in a data for most domains. So, but let's say you have somehow decided that you know the data is noisy and you would like to somehow fix it. So there are some very simple techniques, and these are usually techniques from smoothing that you can apply to smooth out the data. And the whole notion of smoothing is, as I said, values that are nearby in time and space. So those are good indicators of the value that might be missing or that might be noisy. So you use those values that are recorded nearby in time and or space to fill in or readjust the value that is noisy. So binning is a very simple technique. You can sort your data, and of course, this is only possible if your data is sortable, which means that ordinal and higher. You sort the data, and then you decide whether you want to do uh, whether you do equi-width or equi-depth binning. Equi-width means that you create uh, bins that whose ranges uh, basically the values have fixed intervals over the range of the values of your attribute. Equi-depth means that each bin has this, the number of values within each bin remains the same. And then, of course, you bin those values. Then once you have bin the value, you take the values within the bin, either compute the mean, median, or mode, and use that to replace all values. So that's kind of a way of very crude smoothing of the data set. So maybe I can take a quick example, although it's very simple. It's also running out of time, actually. So basically, let's say if you have a value 2, 5, 3, 8. So let's say if I do equi-width binning, so of course, this is the original value. You have to sort it. So if you sort it 2, 3, 5, and 8, okay? And then if you do equi-width, meaning that you have a range from 2 to 8. So you need to divide this interval. Let's say, again, you need to decide the number of bins. So let's say if I do 2 bins, ठीक है, I think I will probably stop here. आप लोगों को थोड़ी टेंशन होनी शुरू होगी क्विज की. So meanwhile, एक आध का कोई क्वेश्चन है क्विज का, आप पूछ सकते हैं क्विज के लिए. I'm pretty sure no one is paying attention to what I'm speaking right now. So the quiz will start around 1:35. You have 10 minutes to complete it. And you can look at other material, but it should be on your computer or uh, on printed page. You cannot browse or search the web. तो ये आपने ध्यान रखना है, browse or searching the web is not allowed. आप कोई चीज क्वेश्चन उठा के वेब पे डाल के वो नहीं कर सकते आप, ठीक है. एंड ऑफ कोर्स यू कैन नॉट स्पीक विद एनीवन, और कोई व्हाट्सएप या कोई और ग्रुप से आप मैसेज नहीं कर सकते. एंड वी विल ऑब्जर्व दिस एंड मे बी थोड़ी बहुत ये जो है हमारे पैरामीटर्स चेंज हो सकते हैं एज वी मूव ड्यूरिंग दिस सेमेस्टर. एंड ऑफ कोर्स कैमराज अपने ऑन सारे कर लें so that we are able to observe you during the taking of the quiz.